My name is Christopher Xu, and this is my C++ midterm project, and I'll be explaining my code right now. So first of all, I have a lot of include header files. I include the IO stream header file, and this allows me to use input and output objects such as cout, cin, and endline. Next, I have the include vector, which allows me to import the std vector, and I'll be using that in my code to tell the user where to hit the enemy and allow them to sort of use vectors as coordinates. I'll show that later. Next, I have the include header string file string, which basically allows me to use the std strings. Next, the header file include utility. It allows me to use the std pair and other utility types. The fstream header file also imports the if string and output string file in order to get user input and write user output to a text file. Next, I have the include random. This allows me to basically use any sort of like random number generators. Then we have IO manip. This allows me to format the output, such as excluding decimal points or writing numbers that include decimal points. Next, I have the header file include limits. This can imports numeric limits used to clean up input. Next, using std.cin, this basically allows me to just write in the code, just write cin instead of std colon colon cin. Like for example, std colon colon cin, I will not have to write that. I can just write cin like this. And that's what every single one of these using things does. Like for this one, I don't have to write std colon colon cout. I can just write cout, and same thing for all of these. Next, I just include some variables like static constant integer board size, which is just basically the size of the board of Battleship we're going to play, which is going to be 10 rows and 10 columns. Next, I have the static constant characters, water, ship, hits, and miss. These are just going to represent different pieces on our board. Water is represented as an O, ship is an S, hit, whether you hit an enemy is represented as an X, or if you miss them, is represented as a M. Now in my ship class, I start off with making the following members private: string name and string name, size, vector, and the string name, int size, vector pairs, coordinates, both of them are integers, and integer hit points. Next, inside my public code ship, what I do is this is basically the default constructor. This initializes an empty ship with a blank name and zero as the size and hit points if the user just doesn't type in anything. Next, I have another constructor. If the user does input something, it's going to be string, which is going to make the name to whatever the user input, which is n. The integer size, whatever the user input, is going to be the size, and the hit points will also be whatever the user inputs. Next, the string get name is a getter function for name. It returns a constant reference of the name variable. Same thing for size, it returns a constant reference of the size variable. Same thing for hit points, it returns a constant variable of hit points. And we have a constant vector. Now, for the vector, we are going to um, this is a getter for the coordinates list, and we return a constant of the coordinates, so whatever the user input. Next is void set hit points. This is our setter function used when loading from the save file to restore our HP exactly. Next is the void place ship. This is just a method assigned to the ship's coordinates. Let's see, and coordinates is equal to chords, whatever user input right here, and if the hit points are if the hit points are less than equal to 0, then hit points is just set to size as a failsafe if the user doesn't type in hit points correctly. Next, the uh, next we have the void receive hit. Void receive hit. This method is called when the ship is hit. Then we have if hit points is bigger than 0, then we just decrease hit points by 1. Next we have another function, boolean is sunk, which um, returns hit points equals 0, whether that's true or not. And if that's true, the function will return true. If that's false, it will return false. And is basically used to tell us when the other player's ship is sunk. Next, we have Boolean occupies. In this function, we have a for loop, constant auto. It's just a range for loop ranging through each coordinate pair p. P in the coordinates. And if p dot first is equal to r and p dot second is equal to c, return true. Basically, if the coordinates matches the row, which is what r represents, and column, which is what c represents, return true. Else returns false. Now we begin in our class board. For some private members, we have the vectors, which we have the we have the vector grid. It's a 2D grid of characters representing the board. And next we have a vector of ships, which is just a list of ships placed on this board. Next, the function bool inbounds. It gets the input of rows, a number of rows and a number of columns, and it returns whether turns true if row and columns are within the bounds. Like let's say if the rows is and columns are larger than the board size, then this will return false because obviously we cannot have that. Next, in the public constructor, we initialize the board to empty water and clear ships. Next, we have a constant vector that returns the grid. That constant vector that returns the grid. Next, we have another getter function that returns the ships, and another one that returns ships by a non-constant reference. This allows us to modify the ships directly. For the set grid function, it replaces the grid used for when you load in. So let's say you save the game and then load into a new one, then this will help you restore the game from your save point. And then the void set ships, it replaces the ship list with the ship list you saved during your loading. Next, boolean can place at. So what this function does, um, it loops over each coordinate. It loops for p in each coordinate, and it sets it extracts the row and column from p, p dot first, and c equals p dot second. So um we'll be inputting numbers into the console, and they will get the first number, which will be the row, and the second number, which will be the column. If this is out of bounds, then just return false. If the grid cell isn't water, then it must be overlapping existing ship and must be invalid. Otherwise, return true. That means all coordinates are valid and empty water is empty. So now we have a function boolean place ship. We have a constant auto cores. These basically gets a ship's coordinate list. Next, if the chords are empty, then placement fails and obviously return false. If it's overlapping or out of bounds, as see right here, you can't place that, then you have to return false. Next, for looping over each coordinate, yet again, the grid, we get p dot first and p dot second. Mark that cell as S on the grid. This is basically putting up our ships on the grid. Next, we just ships.pushback ship. What this does is store the ship object in this board ship list, and if it succeeds, then we return true. Our next function is going to be receive attack. If this is not inbound, coordinates are not in the game area, then we have to return invalid coordinates, tell the user that. Else, if the grid is equal to hit or grid RC is equal to miss, then that means this cell has been hit or already has been mid. And we have to tell the user they already attacked our spot and you need to try a different coordinate. If there's a ship at that cell, then just mark it as a hit. Next, we loop over all the ships by reference so I can modify their hit points. If S dot occupies RC, that means if the ship has already occupied an attack cell, then decrease that ship's core hit points. And if it just became sunk, then we have to return and tell the user that they sunk the other player's ship. Then return a hit message, return another hit message. So for the grid RC, if otherwise out of this, if you miss all your attacks, then we just mark that cell as a miss and return. Boolean all ships sunk. We loop over all of these ships in our list, and if any ship is not sunk, that means the board is not the quote unquote defeated. So we return false. But if all the ships are defeated, then we return true. This method display board, it basically prints the board to the console, type in a new line. We loop over the board size, get empty spaces. Then uh, another for loop and size. We just type in a bunch of empty spaces for a number of columns and a bunch of empty spaces for a number of uh, rows. Then we loop over the rows and then we print out to console the grid. We do that for each row. Then for my new class, the RNG class, this is the comment separator. It uses a Mersenne Twister random engine. It is basically uses a random number generator to generate random seeds, but in this case we will be using a deterministic seed as okay for grading. That'll be easier for grading. And this is our seed sequence. This is a sequence I made of myself. Create a seed sequence from these integers and then see the RNG with that sequence. Next, the function returns a random integer between low and high exclusive. This defines a random uniform distribution over low to high and returns and produces and returns a random number using the engine. Then we end that little class over there, the RNG class. Now we are in the game class. Start the game class. We have two objects, board player one board and two board player two boards. We also have a integer current player. It could be one or two, and the RNG object RNG random number generator for ship placement. Vector, we have a vector ship make default fleet function, basically creating a fleet list. We returned ships with carrier size 5, ship with battleship size 4, cruiser size 3, submarine size 3, and destroyer size 2. We have we make another vector pair of two integers, create an empty coordinate vector, uh, and also in here assign that to coordinates that reserve size. It pre-allocates memory for more efficient code. Next we have a for loop, loops through the size. If R is horizontal, the row stays the same. If it's vertical, the row increases. Same thing for this. If it's horizontal, the column increases. Otherwise, it's vertical. A vertical console stays the same. Then we just push back the coordinates. store them, and return coordinates. Next, we have an auto place fleet. What we do is for this, the function automatically places all ships onto the board. Auto fleet, um, auto fleet is here making the standard fleet. Next, calling through this, we loop through each ship by reference in the fleet list. We have a bool place equals false. It tracks whether the placement has succeeded. Next, for our for loop, we try up to 1,000 random placements until we have successfully placed our ship. Bool horizontal, it randomly picks an orientation. Over here, max row is the max starting row that keeps the ship inside the board. Next, the integer max c is the max starting column that keeps ships inside the board. And two integers, int r and c, this is representing our random start row and our random column. Next, auto coordinates equals make coordinates rc ship.getSize and horizontal. This generates the coordinate list. Next, ship.place ship coordinates. We store coordinates onto the ship. If boards.place ship is true, then we attempt to place the ship on board, checks if it overlaps or is out of bounds. If it works, then place equals true. If it somehow couldn't place as demonstrated here, then we then we have to reset the board and just try again recursively. And we have to stop the current function after the recursion starts. Next, void.clear input line, we just clear the error flags on our cin, and cin.ignore numeric limits. It basically, what this line does, this line is ignoring the remaining characters until we have a new line. Next, for the read int variable, this is used to read an integer safely with prompt. We have a infinite loop until we get out prompt. We print out the prompt, a clear variable v. If reading is successful, then we return that variable. Else, if failed, we print the message invalid input and please enter a real number. Then we just clear and ignore the garbage input. Void show boards is to display both of these players' boards, player 1 board and player 2 board. Next, for the Boolean handle attack, it handles one attack action and returns real if a real move has happened between player 2 and player 1's board. Next, it asks the player to enter attack coordinates as two integers, 0 to 9 for row and column. Then we just read whatever they type in using read int. Next, the string result equals enemy dot receive attack is applying the attack here, attack formation here, and getting a message. Next, we just print out the result. For result.rfind, if the message starts with invalid coordinates, do not consume the turn. Assume false. It's still your turn. You just have to choose another coordinate wisely. Same thing for the you are already attacked. If the message says you are already attacked, then do not consume turn. You'll have to choose another one. Otherwise, it returns a valid move. We have a public part of the game. The constructor sets player 1 to go first over here. In the void start new game, player 1 initialize their board, player 2 initializes their board as well, and automatically places ship for player 1 and player 2. That sets the current player to 1. We have a function void switch player. We switch the player uh, with a certain condition. If the current player is 1, then switch to 2. Else, if the current player is 2, then switch to 1. Boolean save game. It just this is the function for saving all states to a file. We open a OF string for an output text file. If it couldn't open, then just return false for fail. We type in battlefield save v1 current player and the current player number. Auto write board. What this entire block of code does is it writes a lambda function to write one board section. It then marks which board it is for player 1 or player 2 and label for a grid section. Next, it gets the board grid, loops over the rows and columns, and types in a new line after them. Next, we type in how many ships follow, loop over the ships, write the ship's header, part 1, and write hit points and number of coordinates, then new line. Then we have to loop over each coordinate, then write the row and column for that part. Then just end board. We're one uh, we print out player 1's board and then player 2 boards and then end the save. What this code does is it loads the game state from the file. It opens the file for reading. Then if the reading fails or returns false, we have a string header to prepare the string for the first line and another string to read the first line. If the header does not equal battleshape1, then we have to return false. If a string key, that means the string token variable, then we just read the next token variable using int. If key does not equal current player, then we return false, as the player must be the current player. Then we have to just read the current player number. For the auto read board, we have auto read board. We read lambda to load one board. We have more variables for tokens. You read 2 tokens. Next, we get to the grid. If grid does not equal grid, it must be a grid variable, so we have to return false. Next, for the vectors char, we prepare a 10 by 10 grill to fit. Have a row string to consume. This consumes leftover new line after reading grids. Then after here, we just loop 10 rows and read the full row line of charts. Then we validate the line length and store char in grids. Next, this is the string ships token, the ship count variable, and we have to read ships and the number. This must equal ships. If it doesn't, it turns false. We have to prepare ship vector, then reserve memory, as this is a very taxing on the computer. Next, for for size, t equals 1, 1 is less than ship count. We loop over each coordinate string ship token, row and column. We read them. Ship token is not equal ship, must equal ship, and return false. Next, another function we have is the running gameplay loop. It loops forever until you return and prints both of these boards. Then it checks if player 1 has won, then outputs that player 2 has wins. Then it checks if player 2 has lost, then that would mean player 1 has won, and prints out their respective win messages. Next, we print out the current player's turn. We have multiple options for attack options, saving the game, and quit to main menu. Then we read whatever the player's choice is from the console, and we print out choose an option. Then we read their choice. If the choice is 1, then they consume a turn. And the attempt attack consume turn is true if valid. Next, if the player board .1 all ships sunk is checking win again after the player has attacked. It shows the board, and if player 1 has all their ships sunk, then the player 2 wins. Same thing, but vice versa for player 2. If player 2's ships have all sunk, then player 1 must have won. Else, if the choice is 2, then all we have to do is save the file. We get the name of the file, and then we say that we save to that file. Else, if the save file couldn't work, then save failed, and we need to check the file permissions or path. Else, if we type in 3, that means return to main menu and just return out of the gameplay loop. Else, if you don't type 1, 2, or 3, is an invalid menu option. Finally, we are onto our main game. In here, we create a game object game, and while true loop infinitely, we start our game, the text-based battleship. We ask the user to either create a new game, load a previously saved game, or exit. We have another choice. In choice, we ask the user to choose an option. If the cin couldn't work, then the reading integer fails. They have already typed in use letters, then we clear the error flags and discard the rest of the trash line the user has input. Next, we tell them they have done an invalid input and restarting the menu loop to tell them to choose a valid option. If choice is equal to 1, then we start a new gameplay loop. Else, we ask them to name the file to load. And if the choice is 3, then print out goodbye and exit the main loop. Else is a invalid menu option. Finally, return 0 for a successful completion of our code. I'll show you an example of the code running. See, this is players 1 board and players 2 board. This is a set seed, so it'll be the same for all of the seeds. I can save the game. I'll type in battleship.txt, save that there. I can quit to the main menu and load a previously saved game. Let's see, battleship.txt. See, we have our exact same board back. It's pretty neat. Now we can actually start to attack people. So what this does is, yeah, in here I can, let's see, I'm player 1, so let's see, players 2 boards, I can attack row 4 and column 0. So try row 4, column 0, and you can see it's a successful hit. Now is player's 2 turn. Let's see an example of a miss. Or first, let's see what happens if we type in an invalid option. So row -1 and row -2. Tells me that is an invalid coordinate, so let's try to miss on purpose. On a attack row 3, column 4. We most likely missed the player. 3, column 4. Oh no, we actually hit them. Okay. Let's get an example of missing. So attack players 2, row 0, and column 0. See, as you can see here is a miss. And now I can type in 3 to quit the main menu and exit the game. And that is all.